Here's the other combination circuit like the kind we had in the lab. This one, you can very easily tell, is a parallel circuit with series bits. If it's not visually obvious, look at the total current coming out of the battery pack. The first thing you hit is a junction. That means you are destined to be in series. One branch current here, I1, and a second branch current here, I2. The two of them will, as usual, join up together in the end to make the total current. As is usual, draw your black boxes, find the total resistance and the total current. In this case, the voltage drops will be very straightforward. It's the branch currents that will require a little bit of extra work. Press pause and press play when you're ready to check your work. Here and here, with 1200 ohms here and 20,000 ohms there, give you total resistance of about 1100 ohms. Quick fact check. This is smaller, slightly smaller, not more than 1 order of magnitude smaller than the smallest, in this case, not resistor, but the smallest branch, the smallest black box. Don't round this early. You'll get rounding errors propagating through. Save your total resistance on your calculator and estimate the final answer when you get to the final answer, which in this case is a total current of 7.95 milliamps, which will carry through earlier in the problem. 7.95 milliamps branch out here to the first branch or here to the second branch. Which branch do you expect to have more current and why? Press pause and press play when you're ready to check your work. Sure enough, 7.5 of the 7.95 milliamps go to the branch with lower resistance with a measly 0.45 milliamps. Notice we're really getting into microamps here, going to the branch with the higher resistance. This is the information we need to get the voltage drops up here in this circuit. Label all of your branch currents and label your individual voltage drops. Press play when you're ready. Branch here on the right, branch 2 with a smaller current. It's easy enough to see. Voltage drop in the 12 kilo ohm resistor is the current flowing through times its resistance. Well, on branch 2, the current flowing through is 0.45 milliamps. 0.4 of the 9 volts are used in the higher resistor, and that leaves, watch this, this is real clever, that leaves the other 3.6 volts to be used in the 8 kilo ohm resistor. Check it out. You haven't hit anything else in this branch. 5.4 volts used to power this, 3.6 volts used to power that. You got a straight shot back to the battery. Try it again. For the first branch, you should get 7.125 volts, about 7.1 volts of voltage drop in the larger resistor, leaving 1.875, about 1.9 volts of voltage drop in the smaller resistor.